Alright, day 2, here we go. We are going to learn how to solve quadratics on Monday, okay? But we're going to learn how to do it a couple ways, and one of the first ways that we're going to learn how to solve is by factoring. So we need to make sure that we review factoring. This should all be review for you guys. So I'm actually only going to do a couple of each problem, and then I'm going to let you guys have the rest of the time to work, okay? So there are a bunch of different ways that we learn how to factor. And the first way that we learned how to factor was this method called the short method. So the short method is when you just take a look at your trinomial and you find the factors of negative 12 that add up to negative 1. So what are two numbers that when I multiply I get negative 12, but when I add them I get negative 1. So let's see, I can do 1 and 12. Okay, I can't get 1 that way. I can do 2 and 6. Still can't get negative 1 that way. I can do 3 and 4. So I can actually get negative 1 by doing 3 and negative 4. So let's take a look at these. When I multiply these, I get negative 12. That's what I want. And when I add these, 3 minus 4, or 3 plus negative 4, I get negative 1. So these are the ones that work. And when I factor this, the short method means I'm already done. This is a positive 3, so this becomes x plus 3. And this is a negative 4, so this becomes x minus 4. And that's it. There's your answer. Okay? Now, this method only works when you have nothing next to your quadratic term. So that means in number 2, I've got nothing next to n squared. It's like having a 1 there. So that's the only time you could do this. So in this case, I want to find factors of 42, negative 42, that add up to negative 1. You can go through the list, or if you know right away, you can just jump to it. So I know that to get 42, I can do 6 times 7. And how could I get negative 1? Well, that would be 6 and negative 7. So we look at them. 6 times negative 7 is negative 42, and 6 and negative 7, when I add these together, I get negative 1. So this would be n plus 6 and n minus 7. Still called the short method. Now, when you look at number 3 looks more challenging, okay, because you have a number next to your x squared. You have a 3 here. So before you guys start doing the long method, and we talked about that one, look at all my numbers. I got 3x squared, I've got negative 30x, and I've got 48. All of these are actually divisible by 3. So let's take out and let's divide them by 3. So we're going to put that 3 on the outside. And now what's left? Well, these 3's will cancel, so I'm left with x squared. Negative 30 divided by 3 is negative 10x. And 48 divided by 3 is a positive 16. Now when you look at this thing, there's nothing next to x squared. So now you can go back to the short method. So, short method. What are the factors of 16 that add up to negative 10? 1 and 16. Can't get 10 that way. 2 and 8. Oh, I can get negative 10 that way. But that means that negative 2 and negative 8, they both have to be negative. Check it. Make sure it works. When you multiply these, are you going to get positive 16? Yes. If you add these numbers together, will you get negative 10? Yes. So, your two answers would be x minus 2 and x minus 8. Do not forget, you guys divided out that 3, you took that 3 out, you need to put that 3 at the bottom as well. And that's the short method. Okay, now let's go down, and I'm actually going to block these off. Those first 6 problems, they're all going to use the short method. Okay, so I'm giving you that little hint. So let's write short right here so we don't forget it. Okay, now let's jump down to number 9. I have a 2 next to my quadratic term. But if you notice, these numbers are not all divisible by 2, so you cannot factor out a 2. So since I can't get rid of this 2, there's a different method. It's called the long method. Alright, now we've done this before, so make sure we're very careful when we follow along. The long method means you take that 2 and the 15, and you multiply them. 2 times 15 is 30. You want to find the factors of 30 that add up to 13. Now, do you know them off the top of your head? Okay, you got it. It's 10 and 3. When I multiply these, I get 30. When I add them, I get 13. It's called the long method for a reason. It takes a while. So this is the process of the long method. It's actually called splitting the middle term. Okay? So what you do, if we're going to split the middle term, we're going to break this 13n up into my two factors. So I have 10n and a positive 3n. Okay, so what happens to this 2n squared and the 15? These just drop. So it would be 2n squared plus 10n plus 3n plus 15. Okay, so these things just drop. So now that you have 1, 2, 3, 4, 4 terms, we're going to group them, and we're going to take out a GCF. So what can you take out of the first two terms, the 2n squared and the 10n? 2 and 10 are both divisible by 2. And if you notice, they both have an n in them, so we're going to take out a 2n. If I take out 2n, my first term, when I cancel things out, I'm just going to get n left over, plus these n's will cancel, and 10 divided by 2 is 5. Okay, let's look at the second grouping. I have 3n plus 15. What can I take out of 3n and 15? You got it. I can divide them both by 3. So if you take that 3 out, we're going to put that outside the parentheses. The 3's will cancel, and you'll get n, and then 15 divided by 3 is 5. You know if you did this right because look at your parentheses. They should be exactly the same. N plus 5, n plus 5, so one of your parentheses is n plus 5. The other parentheses is made up by what's left over. You have a 2n, and you have a plus 3 on the outside. So the other one is 2n plus 3, and that is the long method. Alright, let's try another one. Okay, so I'm going to block these off. I'm going to say 7 through 12. These are all long method problems. So you know, and it's just going to help you. Alright, let's try it again. Okay, let's go to number 12. I have 7 and 12. I'm going to multiply these. 7 times 12 is 84. Now you need to find the factors of 84 that add up to negative 31. Now at first it might seem like these are pretty hard to come by. I understand that trying to find factors of 84 that add up to 31 can be pretty challenging. So let's write them out one at a time. How can you get 84? And I'm going to put these out to the side. You can do 1 times 84. Okay, you can't get 31 that way. So let's go 2. That would be 2 times 42. Okay, you still can't get 31 that way. So 3. 84 is 3 times 28. Can you get 31 that way? Absolutely. So, to get negative 31, that means that 3 and 28 have to both be negative. If you multiply these, will you get 84? Yes. If you combine these by adding them, will you get negative 31? Yes. So these are my two terms. I'm going to split the middle term with these two. So the 7x squared drops, 7x squared, and the minus 31x gets broken up into minus 3x and minus 28x. And then that plus 12 drops. Alright, same way. Now that I have 1, 2, 3, 4 terms, I'm going to group them. Make sure that negative is inside the parentheses when you group them. What can you take out of the first two? These first two terms, I can only take out an x. And if you take out an x, you're going to be left with 7x minus 3. Okay, now the goal is, if this came out to be 7x minus 3, this next parentheses, you want that to be 7x minus 3 as well. Okay, that's how we know we did this right. So the question is, what can I divide these by? What's my GCF that I can take out to make sure it works? And to get a positive 7x, that means I'd have to divide both of these by negative 4. So if you take out a negative 4, negative 28x over negative 4 is a positive 7x. Okay, so now those match. 12 divided by negative 4 is negative 3. So now these match. So both of my parentheses now match. That's fantastic. That's what I wanted. So 7x minus 3 is one of the parentheses. And what's left over? The x and the minus 4. So x minus 4 is the other parentheses. We are all good to go for this one as well. That's the long method. Okay, next group. People always seem to like this group a little bit more. 13. You only have two terms, 1, 2. And if you notice, they both have a p in them. So we can factor out or divide out a p. So if we take that p out, we'll be left with p minus 10. That's it. 16. Let's look at 16. We have 5x squared minus 20x. There's only two terms here. So what can you take out from both of these? We're just going to do a GCF here. So these are all called GCFs. Greatest common factor. They're both divisible by 5, so we can divide them by 5. And they both have an x, so you can take an x out of both of them. So when you take out that 5x, you're left with x minus 4. And that's it. Okay, so 13 through 18, so turn it over. Those are, that's it. Those are all GCFs. Okay, 19 through 24. These are a little bit different, okay? Number 23, there's only two terms here. But if you notice, we don't have a GCF. There's nothing I can take out of the first term, x squared and 81. But there's something else I can do. If you notice, these are both perfect squares. 81 is a perfect square. I can take a square root of it. So what we call these are the difference of two squares. Difference of two squares. Okay? Now, if you notice, we have an x squared term, we have a c term, we're missing the middle term. Okay, this has happened before to us. When we have conjugates, the middle terms cancel. So what we're going to do is we're going to create conjugates here. Okay, so what I say is, you have x squared, you have two x's. We're going to send one x to one parenthesis, and the other x to the other parenthesis. 81 is a perfect square. What's the square root of 81? You got it. It's 9. So to get 81, would you agree it's 9 times 9? Alright, so that means we're going to send one 9 to one parenthesis and one 9 to the other. And then really, I've got a negative 81 here, so that means that one of these 9s has to be negative. So we're going to do 1 minus and 1 plus. You've now created your conjugates, and you're done. Okay, now, let's go to 22. When you look at 22, these are not perfect squares. You can't take the square root of 2, you can't take the square root of 128. But if you notice, both of these numbers are currently, you can divide out a 2. So let's take out the GCF. You should always try the GCF first. If you take out a 2, you're left with x squared minus 64. Okay, now you have something that you can do. So I've got two x's, so we're going to send one to each parenthesis, x and x. 64, the square root of 64 is 8, so let's send one 8 to each of those. So because like 8 times 8 is 64. Put the plus and minus in, and then drop that GCF. That 2 has to drop from the outside. And you're good to go here. Alright. I'm giving you a lot, but I got one more thing to go over, and then we're all done for today. The rest of the time you guys can spend on your homework. These last 8 problems, these are new to you guys, okay? But you've actually done this a bunch. You have how many terms? Let's look at 25. If you look, you have 1, 2, 3, 4 terms. Okay, you can leave your paper here, just look up at the screen. This has happened before in the long method problem. See how in the long method, when I look at number 9, I started with 3 terms, but then down here, I had 4 terms. We're going to use the same approach. What did I do when I had 4 terms? You're right, I grouped them. So, let's go back to that problem. Anytime you have 4 terms, 1, 2, 3, 4, we are going to factor these by grouping. And it's the same way that you guys grouped them before. You take the first 2 and you group them. You take your second 2 and you group them. Let's look at the first parentheses. 12p to the third and 3p squared. What is the GCF here? 12 and 3 are both divisible by 3. I've got 3 p's in the first one and 2 p's in the second one, so I can take 2 p's from each one. So, if I take 3p squared, what would be left? 12 divided by 3 is 4. I had 3 p's, but I took 2 out, so that's p. And then over here, you notice how 3's cancel and p's cancel? Everything cancels. But anything divided by itself is 1. Alright. The second group, negative 20p minus 5. Well, they're both negative, so what I'm going to do is I'm going to divide out both things by negative 5. So if I take out a negative 5, negative 20p divided by negative 5, this is 4p. Negative 5 divided by negative 5, same number, anything divided by itself is a positive 1. So again, your parentheses are matching, and you need them to match. If they don't match, something went wrong. So one of your answers is 4p plus 1. And then what's left over? We have 3p squared minus 5. Alright, home stretch. Let's do one more. 32. I've got 4 terms. 1, 2, 3, 4. So let's group them. Group the first 2, group the second 2. What can you take out of the first 2? You can take out n squared from the first 2. So, if you take out n squared, let's figure out what's left. Over here, the first term you'd be left with 8n. And then over here, n squared and n squared would cancel. But I need something, anything divided by itself is 1. So 8n minus 1. Okay, now, the second one, the first term is negative. I want it to be positive. I want it to say positive 8n. So that means I have to divide out a negative. 56 and 7 are both divisible by negative 7. So we take out a negative 7. And then negative 56 divided by negative 7 is 8, so that gives me 8n. 7 divided by negative 7 is negative 1. The parentheses match, 8n minus 1. And what's left over is the n squared minus 7. Okay, this one took about 20 minutes to get through, which means for homework this weekend, or for the rest of class time, you guys have to finish this worksheet. Okay, that is your homework. I'll be back on Monday. We'll go over it all. I'll take any questions. So make sure anything that's confusing you, you guys write it down so you can have me know. Okay, so we can go over it. All right, have a great weekend. Good luck with this worksheet. Work together. Work hard.